Hello, this is Dr. Duello, and I have a presentation here on identifying undergraduate research opportunities on campus. And this can be a pretty difficult task, especially large universities have many opportunities, but how do you go about finding an opportunity? You can spend your weekends looking at dozens and dozens of sites, but how do you proceed? So this is what I want to talk about this presentation. So what is research? To search for knowledge or any systematic investigation to establish facts. Doesn't matter which discipline it is. The scientific method has standard components. You ask a question, you gather information about the question, you form a hypothesis. You determine the variables, which ones are variables, which ones are fixed. You design an experiment, you analyze the results, and you report the findings to others. So what's the value of research? Some people will think, well, if I'm not going to be a scientist or I'm not going to pursue a PhD, there's really no point other than the fact that I get to put it on my resume. I get to put it on my CV. That's the wrong way to think about it. Research teaches analytical thinking. And I can tell you it's really important because admission committees will often look at whether you've conducted research and maybe your math scores to determine if you have learned how to be an analytical thinker. So one of the rubs throughout my career is that I've always heard, that the health professions are helping professions. And I do a lot of pre-health advising, but that still rubbed me because I thought, you know what, research is a helping profession. It doesn't happen in 5 minutes or even 24 hours, but absolutely, research is a helping profession. So you're going from the analytical thinking, which is the scientific method, to deductive reasoning, and this is the basis of differential diagnosis. You have a patient with all of these symptoms. How do you deduce which ones are significant, which ones aren't, and to come up? So even if you're going into the health professions, research is invaluable. I can't tell you how many times, though, I have looked at essays and people think, well, I did research and that's as much as they have to say, or I did research, we studied Drosophila, and that's it. And if you haven't demonstrated that you learned the analytical thinking, then basically as an admissions committee member, I'm not giving you any points per se for having done research. So in my early career, I realized that this was particularly difficult for a lot of students, and I encouraged students to come in and to talk to me about how to find a research position. And I would say, what do you have in mind? And they say, I have absolutely no idea where to start. None whatsoever. So I'd say, well, what are you interested in? And these are undergraduates who haven't had a lot of experience yet, so sometimes I don't know. Sometimes everything. A little hard to narrow things down from everything. So sometimes I would say, is anyone in your family ill? And we all know somebody who's ill. And then we went from disease processes to types of science, so we can always narrow down something that you're really interested in. So I want to facilitate students being able to find research opportunities. And I'm going to go through these slides, and then there's going to be a handout that you can download too on how to approach a professor to seek a position in a laboratory. You can seek a position for pay, and they may be advertised. You may be able to do it that way, but I really recommend that you do research for academic credit. At the University of Wisconsin-Madison, every department has a course number 699 Directed Studies, and this is the course number on which you can sign up for research after arranging it with a professor in any particular area. So the advantage of doing it as an academic pursuit is you do well, it incorporates into your grade point, and sometimes when you go through admissions process, they'll ask you for letters of recommendation, but they'll say somebody, professors who knew you in an academic setting. So rather than volunteering, you do this as a course, and you are able to use that person as a recommender as well. So lots of reasons. So I've put together some of my own ideas and resources here. The first we're going to talk about is I have produced a list of departments and programs by topics. The university lists them alphabetically, but then you have to read the whole thing or know what we have in order to look for it alphabetically, so I've done it by topics. I'm also going to talk very briefly about a database called Community of Science, another huge one, Pubmed, which is all the medical literature, and then I'm just going to touch on summer research opportunities, but I'm going to give a whole nother talk about that you'll also find at this website. So first off, this is the list that I produced because I think students think in terms of topics. So what I did some night when I had insomnia was I put in order all of the departments that are involved in biology. And because science is so interdisciplinary, there are biochemists, molecular biologists, cell biologists in many, many, many different departments, in many, many, many different training programs. There are over 52 programs that offer a PhD in some aspect of biology here at the University of Wisconsin. So here you can find, these are all biology areas. I also divided it up into physical science, mathematics, statistics, and computer science, engineering. Categories I call everything ag, everything agriculture, everything geography, etc. So that you can more easily find departments that you might want to look at. This slide is to just make a point about interdisciplinarity. So what it just shows, if you look at the X's, is over on the left we have all of the faculty in one particular program. In the first column it says ERP. That stands for Endocrinology, Reproductive Physiology. And you can see that this is an interdisciplinary program, and in fact all of the faculty are in many, many different departments. They're not all in just one department. And if you look at the X's across the slide, you can see that they're in many different training programs. So the second column, CMB, is cell and molecular biology. The next, molecular and cellular pharmacology. The next, molecular and environmental toxicology. So it doesn't even matter that you know all these short terms up here, but you can see that any one professor is in multiple programs. So there's multiple places to look, and multiple ways to work with that person, either as an undergrad or a graduate student. So that's the Duello list. The next thing I want to talk about is Community of Science. So what it happens is here we're going to go to the University of Wisconsin homepage, look at libraries, go to databases, and find the COS Pivot Community of Science. So here's our home page, and up at the top it says libraries, and we click on libraries and we go to the next one, and we see that we have our choices, and we can search by databases. So in the database search box we put COS Pivot, Community of Science. You're going to go forward here, and it's going to take you to a website, a Pivot website. And I can tell you that this website has been changed some over time, but what you can see is there's a category for funding opportunities. It says a pre-populated scholars profile. That's what I want you to look at, who the scientists are and where they are, and then collaborative workflow. So any librarian can help you with this. Any librarian would be happy to help you with this. You probably will not find it, or you will not have the same access to it if you just go to the internet, but go through the library, and there will be different functions that are possible. So this is actually a shot of an older website, but it just shows you here at the top where the red asterisk is that you have Community of Science by Expertise, which is this pre-populated scholars program. And on this website somewhere you'll see that you can search by expertise You can search by institution geographically, East Coast, West Coast, whatever, by a specific researcher name or by index words. So say we wanted to have an idea of who in this community of science was at the University of Wisconsin-Madison. And here we have all of these institutions, and we can just scroll down, and there we find the University of Wisconsin-Madison. And as I say, they've changed the website a little bit, so it may not look exactly like this, but talk to a librarian. Now, if we go into the University of Wisconsin-Madison, and you can see our icon at the top, and it's possible there's a search engine here. So the first one is we have all fields. You can search by topic, last name, first name, school, on and on. So let's just say that we want to do a search of HIV. So we put HIV in there and we click search, and what we find is a list of faculty who some aspect of their research is on HIV. Now, is this everybody at the University of Wisconsin who works on HIV? It's all of the people who entered their information into Community of Science. So it's not perfect, but it's certainly helpful. Here too you can see all of the faculty on the left, and in the middle you see that they're in different schools and colleges, and they're in different departments. So you can't just go to one department and find all of the people who work on HIV, which is why this is great. So let's click on Dr. Janet Mertz down here, who's in oncology, and just see what they have for any one professor. So here for Dr. Mertz, they have her mailing address, her contact information, her qualifications, and then she's written a paragraph on expertise and research interests. Now I'll tell you what, you don't have to know everything about a professor's research in order to contact them about an opportunity, but you can look at this and see what she does and look at keywords and have sufficient information to initiate a conversation with her. So here on the next part of this is the keywords that define her research, and also publications. So you can go to these publications. You do not have to read all of them, but if you read the abstract, you can get a good overview of what Dr. Mertz does. The next one that I had listed was PubMed. Now, PubMed is a huge database of all the medical literature, and it's free on the internet because we, the taxpayers, paid for this. If you go directly to PubMed in the internet, then it will give you the information, but you're going to have to go find the publication yourself. If you enter through the University of Wisconsin Library, there are other functions like document retrieval that are possible. So whenever, go through the university to look to use. So here again, we're on the home page. We click on libraries, we go to databases, and we put in PubMed. PubMed is going to take us to this huge database of all of the medical literature. And one of the things that you're going to see off here on the left, the fourth one down, is Pubmed Tutorials. So to use this effectively, you can take this Pubmed tutorial, you can go to classes at our library. The librarians would love to help you. This is what they do, this is what they enjoy. They'll be more than happy. They'll also come to meetings and give presentations in this. If you're in science, you are going to need PubMed as a student and certainly thereafter. So the best thing to do is to learn how to use it now and to learn how to use it effectively. So let's go into PubMed, and what this is a humongous search engine. So what we're going to do up here at the very top, you can see search PubMed for breast cancer. So we're going to put breast cancer in, and we're going to click on the search, and what we're going to see here, this is a number of years old, so the numbers aren't accurate, but in this huge database there are 196,546 papers on breast cancer. Now clearly you don't want to read them all, and this is over a long period of time. As I say, this number is even larger right now. So then let's go back to the search engine, and let's put in the University of Wisconsin. And we click on that and find out that at this point in time there were 40,971 publications from the University of Wisconsin. Now this could be Madison or Milwaukee or any other school. We could add that in as well. But now what we really want to know is who at the University of Wisconsin is studying breast cancer. What we're going to do is we're going to take number 1, breast cancer, and take number 2, University of Wisconsin, and we're going to say what is in both categories, and we're going to see 626 papers. Now, that's still quite a bit to read, right? So we probably like to narrow that down. But if you look, you click on it, and here are these 628 papers. Here are the first 20. And you can see that in number 3 here, we have development of anatomically realistic numerical breast phantoms with accurate dielectric properties for model microwave interactions with the human breast. Way beyond what I know, but fascinating. Just for demonstration purposes, if we click on this site right here at 3, it now takes us to an abstract of that work. So you're going directly to a summary of what is known here. And I'll tell you what, if you need to speed read, you read the first sentence and the last sentence to see what they did and what they found. If we look up at the top here, you can see across it there's something, and it's got all, number 1, and then it has review, systematic review, and full text. Now the point is that oftentimes scientists write review articles, and what it is they have looked at many papers in the literature and they're summarizing that work in a review article. If you write a review article, and that's just what it's called, then you may have reviewed part of the literature that you consider the most germane. If you do a systematic review, it means you've looked at everything. So if you want to get into a new research area, you probably don't want to read 626 papers, but you probably want to look for review articles which are going to give you an overview of the area. This is great for getting ready for discussions and seminar classes and that too. But this is how you do it. You can see off on the right side too, there's a red button that says Find It. If you have gone in through the UW website, rather than directly into the internet, you can click on that Find It, and it will tell you how to electronically get that article delivered directly to your computer. Couldn't be easier. So let's go back here, and again we're looking at breast cancer at the top, but there are many ways to refine your search rather than looking at 626. And again, definitely a librarian can help you with this. At the top you'll see right under PubMed it says limits. So if we go to that category, you can see that we can search by author or journal, full articles, whatever. And down here at the bottom we can do human research or animal research, or gender, male or female. So you can narrow down those 626 papers. You can also go with different languages. If you speak German and French, there you go. If you're like me and unfortunately only speak English, I could look for only English papers written in English, but I probably want to look at everything for thoroughness, and because oftentimes, even if a journal article is in a different language, the abstract may be provided in English too. Up here in the upper right, you can see we have clinical journals, dental journals, nursing journals. You can search by topic. Fantastic. On the lower left, you have clinical trials, editorial comments, review articles. You can subdivide here. In the lower right, you can see you can do it by age group. I'm interested in low birth weight and infant mortality, so this is a great way for me to look at scientific articles that are birth to 23 months. Low birth weight, Infant mortality is defined as death under the age of 1 year. So in this first category, I should pick up all of those papers. So this is just a fantastic, I've said before, it shouldn't be called PubMed, it should say Mattel, because it's actually a joy to get in here and see what everybody has done. So, does this tell you exactly what to do? Not yet. Also, I'm going to have a document attached here that you can download called How to Approach a Professor to Look for a Position. So people will tell you, well, go look on websites. Well, you can take your weekends, your holidays, and all your waking hours looking at university websites, and we've got thousands of faculty, and you still don't know what to do. So the first thing I do say is to prepare a resume or a curriculum vitae, and you'll find somewhere else on this website how to do a CV. The rules, my rules for this are: number one, always give the professor your contact information on this CV. I have seen people do curriculum vitae, which is your professional history, and it has all of your information except how to get a hold of you. You want to do this polished on 8.5 by 11 paper. I have a joke, it's actually true, that I say never give a professor a piece of paper that's smaller than 8.5 by 11. We will lose it. If you don't believe it, go into our office and look at all the little notes we have posted all over our walls. So do it in a standard format. List your references and state your relationship to them. This is also in the CV talk. If students put references upon request, then you're adding to my workday. Tell me who can serve as a reference to you. So having your resume or curriculum vitae polished, you're ready to go seek a professor. So this is where you want to do a little research to find out about the professor's research before you meet her or him. And like I said, PubMed, Community of Science, UW web pages. If you find a professor and just want to search more, you can go to the home page and do that. You don't have to read all their work, you don't have to know everything they do, but you need to know the keywords and a reason why you would be interested in that. One of the things that absolutely does not work is just to spam professors. Students send out 20 emails to professors, and then they talk to me and they say nobody answered, and their feelings are hurt because I can't believe that these people didn't answer me. Well, these people are extremely busy. Some professors get hundreds of emails every day, and when you sit down with what time you have, you look at the critical ones first. You may have a plan to come back to the other, and you may not find time. So your first attempt is going to be email, but email isn't perfect. What I do back here in this email is tell them maybe how many credit hours, the time you have available, so that you're starting on the same page as to how much time. You have to reserve time for your coursework, for your studying, for any other activities. So it's not reasonable to do 20 hours of work for 3 credits, okay? The next thing I say is if you've contacted them by email and you haven't heard from them, next, call them. And you can call them on the phone. Maybe a good chance that you don't get them because they are so busy. If you don't leave a message, if you don't get them by phone, leave a message and say, I've sent an email, I'm trying to get in touch, this is my number, okay? I hope to hear from you. If it goes on and you still didn't hear from them, the third attempt is actually to show up. Now, everybody may not agree with this, but it works. It's your job to persist, persist, persist. You don't get to whine because they didn't answer your email or they didn't answer your phone call. You go to the lab, and what you do is, number one, voila, maybe the professor is there. Because that professor is so busy, you have another copy of your resume or your CV in hand that you give to him or her. You don't say, oh, it's somewhere in your email, believe me. So if the professor's there, don't waste their time, short, concise, what you're interested in. If not, talk to whoever is available, a graduate student, a postdoc, and provide them a copy of the resume or the CV. A graduate student or a postdoctoral fellow, this is somebody with a PhD, is fine. In many labs, you may be working with another undergrad, a graduate student, or a postdoc, but the professor is still supervising it. So don't avoid these people, because then the graduate student takes the CV to the professor and says, the student came in today looking for, a lab position, and I thought they were dynamite. That's what gets the ball rolling. Also, one of the things you need to learn career-wise is you always take one opportunity and you never let it dead end. You always try to take that opportunity to create the next one. So if the professor says, I am full up, I don't have any positions available in my lab, you say, do you have any colleagues who might be seeking student workers, student researchers, or are there any new faculty in the department? Always try to get that person to help you open the next door, okay? So what it comes down to is that you're now in the lab, and by the third week, literally in the lab, you should know 5 of the 6 answers to these questions. This is the elevator speech, the short, concise speech that you deliver to somebody in an elevator quickly when they say, what do? You want to include with whom you worked, the department, and the university. I worked with Dr. Teresa Duello in obstetrics and gynecology at the University of Wisconsin-Madison. What did you do? Well, at this point, you probably know the project. So it's maybe we're going to study low birth weight in this population. You don't know what you're going to find. That's the one you don't know. But you should know what the broad goal of the lab is. Every professor who writes a grant has a section on significance. Why study this? Why is it important? Why should you give me the money to study this? As I say, we do not study Drosophila because we're interested in the health of fruit flies per se. It's because they're a great genetic model. So all of this, even if you don't have findings yet, you should have talked to people enough to know what you're going to do and why it's important. I'm going to come back to the slide on the scientific method. What was it? Ask a question, gather information about the question, form a hypothesis, determine the variables, design the experiment, analyze the results, and then communicate it to others. You need to think in terms of this process and these steps. I have been distressed when I meet students around the United States who have done research, and I say, this is very interesting, and I say, what was your hypothesis? And they say, well, we really didn't have one. We were just looking at X, Y, and Z. Sure, you had a hypothesis, and you should be able to enunciate it. So talk to the profs, talk to the students, talk to everyone, and make sure that you understand the process as well. Make sure you have somebody check your lab notes too, that you're keeping track of the data in the manner in which you should. So, is this all easy and doable in 30 minutes? No, it's not. It's a bit of work. I hope I can make it easier for you through these slides, through the handout of all of the departments and programs on campus by topic, and by my handout, how to approach a professor to seek a research opportunity. Also, as I say, elsewhere on this site, you'll find out about how to take a resume and convert it to a curriculum vitae. A CV is your professional history. You're going to start that document now, and you're going to update it for the rest of your life. It's not you looking at some path off in the distance. You are on that path right now. So you may do a lot of shopping and a lot of looking, and you may come up with 8, 12, whatever professors. I don't recommend you spam 12 professors. If you need help creating a short list of what I call high probability faculty, send me an email and I'll help you shorten it to 4 or 5 to begin with. There are some people who are fantastic professors, but they may be the head of a director of a large institute, and they're not going to have as much time or as many slots as somebody else. So I can help you, because I've been here for 33 years, determine and locate professors who enjoy having students in their lab and enjoy training them. Good luck. All the best.